Alright, welcome guys to COL 63304, the aromatic ingredients and flavor applications. Alright, so let's look at the first chapter, okay, which is we're going to talk about the history and of aroma and flavors in the beginning, okay. So the learning objectives for today, okay, next slide, is to learn about the history of spice trade, okay, and then the secondly is the to distinguish between the a lot of the terminology, okay, the distinction between what is flavors, what is aroma, what is taste, what is trigeminal sensation, okay. So let's look at the first part, which is the history of spice trade. The spice trade is one of the very important event, okay, which actually looks at the usage of the spice, which is very rich in flavors, and how the spices are going through around the world in the early days. Okay, although now is we got the transportations through flight and things like that, but early stage is either can go through the roads, okay, or by the sea, okay, either the land or the sea. So you can look at it, the flavor is very important in our lives, okay. One of the important thing that why we want to put flavors into our food is actually to impart, okay, to make our food and beverage to taste better, because taste better, humans like food and beverage that taste good, okay. That's why people buy for these, okay. When you go to restaurant, when they say they got new flavor or got a new recipe, you want to try it. If it's good, you will go viral, okay. So early on, the spice trade, okay, let's look at the spice trade. Yeah, the spice trade refer to the trade, okay, the trade between the Asia, yeah, the Northeast Africa. The Northeast Africa is the top right hand side, okay, and is basically of the Africa, and is the one of the closest to the Europe, okay. So these three continents, the Asia, the Northeast Africa, and the Europes, are the trades between them, okay. Spices, for example, like the cinnamons, okay, cassia, cardamoms, okay, ginger, peppers, turmerics, for all these were being traded during that time, okay. So this is the early spice trade route, okay, from the 100 to 1500, okay. So you from here, this is the Europe, right? Europe, Africa, okay. The Africa, the North East Africa side, okay, Northeast Africa side, where they trade, okay, Northeast Africa state, and here is the Asia part, okay, where they trade the spices. So you can see originally during the 100 to 1500, they will trade along the route, okay. You can see from here, okay, from here they will trade here, okay, and go through some of the sea routes, okay, and trade. But what happened is that during the spice trade, what happened is that the route, okay, the route over here are being blocked, okay. You can see from here is being blocked by the Seljuk Empire during the 1090, and by the Ottoman Empire during the 1453, okay. So when they are blocked, they cannot trade the spices. So one of the Italian, okay, one of the the explorer, what we call the Christopher Columbus, okay. So he has an idea. So since there are a lot of blockage from the Europe towards the east side, so he's thinking that why not he'll go from the west side to travel, and from here to go through the Asia, okay, thinking that it will be the closer, okay. Last time, remember, we don't have Google Map and things like that, so they will need to rely on travel and to explore, okay, what we call explorer. So Christopher Columbus instead did not reach the Asia, okay. Instead he landed in the America, okay. He did make 4 trips, okay, 4 trips during 1492, 1493, 1498 and 1502, okay, but none of it managed to reach to the Asia, okay. Instead he has discovered the America, and this has opened up another opportunity for the world, okay. So since since Christopher Columbus didn't made it, so after that they continue, okay, 1500 to 1600. Instead of going through the inner road, okay, now they detour, okay, at the bottom of Africa. So you can see they use this road instead to go into the Europe, okay, the spice trade. Okay, let's watch a short video, okay, about the spice trade. Okay, basically just to summarize what I have discussed or to share with you.
We've all heard the swashbuckling tales of the great explorers like Marco Polo, Christopher Columbus, Francis Drake, and Vasco da Gama. But the great explorers of the 15th and 16th century were not thrill-seeking adventurers who dreamed of discovery. They were hard-nosed businessmen who dreamed of riches and were willing to risk everything to make their golden dreams come true. By the 16th century, the fabled Silk Road, a trading route that ran from China through what is now Kazakhstan, Uzbekistan, and Afghanistan into the Middle East and onto Europe, had been bustling with trade caravans for over a millennia. European traders went east with X, Y, and Z and brought back silks, gold, gemstones, and the most lucrative commodity of all, spice. Today, nearly every kitchen pantry in the Western world contains spices such as cinnamon, nutmeg, and pepper. But in the 16th century, these spices were extremely expensive luxuries, and those who controlled the trade in spice became exceedingly wealthy. Middle Eastern traders bought spice cheaply in the East and sold it to European traders for many times more. Then, in turn, those European traders sold it to their customers for many times more again. This trade was strictly controlled, and the amount of markup that each link in the chain added to the goods as they made their way to customers in Europe were closely guarded secrets. When early European traders finally discovered what the prices were on the other side of the world at the source, they were flabbergasted. In India during the 15th century, the local price of pepper was 3 ducats per quintal. A ducat was a gold coin that weighed about an ounce and was the dominant currency at that time. A quintal was a unit of weight that was approximately 125 pounds. In today's currency, that would be like buying 125 pounds of pepper in Calcutta for $4,000 and then selling it in Venice for $120,000. That's a markup of over 3,200%. Trade in nutmeg was even more lucrative. 1 quintal of nutmeg purchased for the same $4,000 would sell for an astonishing $2.1 million in London or Paris. Today, if you look at the same amount of cocaine, 1 quintal, 125 pounds, you would pay about $125,000 for it at the source and could sell it wholesale in New York for $1.7 million. While this is a staggering profit, it is only a markup of about 1,300%. That is 3 times less profit than a typical nutmeg dealer in the 15th century. Spice was the drug of choice during the Middle Ages. With that much potential for profit, it is easy to understand why the spice sources were so jealously guarded and why those in control of the spice trade wanted to stay in control at any cost. The Italians, particularly the Duchy of Venice, thrived off the trade that moved overland from the Far East and India. Goods passed through the hands of Venetian traders before being distributed to the rest of Europe. Banking, accounting, and mathematics flourished in this trading environment, and the wealth of Venice during the 15th century was legendary throughout Europe. Many were envious. Spain and Portugal even went to war with Italy to try to break their monopoly. They failed. While kingdoms fought for control of this trade, early entrepreneur explorers began pitching the idea of finding alternate routes to the spice islands of India and the Far East. They wanted to cut out the middlemen in Italy and the Middle East and go straight to the source. Christopher Columbus was just one of many who tried to get financial backing for an attempt to find an alternate route to the fabled Indies. He was turned down by Italy, Spain, and Portugal. Eventually, Bartholomew Diaz from Portugal was swept around the Cape of Good Hope by a storm, and the fabulous East lay before him. When Diaz returned from his voyage to Lisbon in 1488 with the news that Portugal was about to capture the spice trade at its source, Spain suddenly found itself being squeezed out of the most lucrative business in the world. So the Spanish monarchs, Isabel and Ferdinand, quickly reconsidered the Columbus proposal. And 4 years later, in 1492, Columbus sailed west to find what he and Spain hoped would be a third and perhaps even more direct route to the spice lands. However, instead of reaching the Indies, Columbus discovered the Americas, and Spain embarked on a project of conquest and exploitation that ultimately rivaled the profits of the spice trade. But that's a story for another time. By 1510, Portugal had command of every link in the spice chain from cultivation to sale in Lisbon, and by the end of the century, the profits from this trade would account for half the Portuguese government income. The rest of Europe, particularly in the north, was profoundly jealous of the Portuguese spice trade and the Spanish discoveries in the Americas. They wanted their own piece of the pie. To get it, they needed to discover what other valuable commodities might be out there in the world. The result was an extraordinary rejuvenation in the whole idea of exploration and discovery that affected all areas of life, but in particular the sciences, engineering, and navigation, and greatly expanded 16th century man's knowledge of the world. Imagine the possibilities that might present themselves if a commodity of similar magnitude to spices in the 16th century were discovered today on some remote moon of Jupiter. A renewed and exciting vigor would be injected into space exploration, and who knows where that would lead. He who dares, wins.
Alright, so that's the video for the Okay, let's continue. Okay, so we have seen the overview of the spice trade. Okay, so century later, nowadays the modern food industry, they create the needs for flavors that were very familiar to the consumers. So you have, for example, like the vanillins, okay, the vanilla flavors, you got apples, okay. You can get any type of flavor nowadays, and you can use it either into food productions, yeah, like for example, you can just add it into, made into like pearls, like the tea life made into the very flavorful type of the pearls where they burst into the mouth during consumptions, okay, like the mango flavor and the strawberry flavor pearls, okay, they call it the pop pearls, okay, and you can see that the we also can add the flavors to improve the existing flavors naturally in the food, alright, or the drinks, and we can use a creative way to add flavors to the snacks, juice, or even water, okay, like the vitamin waters, they added a lot of different type of flavors, okay, like the orange flavors, like the acai, blueberry, pomegranate flavors, okay, just to add more flavors to the drinks. Okay, it's what we call the healthy drink. All right. And we got this what we call the natural confectionery from Australia. They don't use artificial colors or no artificial flavors. They added all natural apple flavors into the snacks. Okay, they call it the snakes gummies. Okay, so it's a chewy. But one thing about this is that it's very high in sugar contents. Okay, for the gummy bears. Alright. Okay. Next, so that is all about the spice trade. The next one is basically we talk about flavors. Okay, so in here we got a lot of terminology, so you need to make sure that you can distinguish, okay, differentiate these different types of the terminology, the flavors, what's the difference between the flavors and the taste and the aroma and the trigeminal perceptions. Okay, all this you should distinguish. Okay, before I enter into the talking about the flavors, let's talk about the some of the origin of molecules. So it's very important for you to first realize where are the molecules that can be coming from. Okay, so basically we can have a few different types. All this will be utilized in the following lectures. Okay, so make sure that you can distinguish these type of origins. The first one is basically you can get it from the natural source. Okay, like they extract the vanillin from the banana beans. Okay, once extracted, the vanillins can be added into your food products like the ice cream, vanilla ice creams. Then the second origin is synthetic, which means that they use chemical they reacted to synthesize what we call the synthetic vanillin. But do take note that they are very similar in they're actually the exact same molecule. Okay, so they taste the same. So again, you can add it into the food products. Okay, to eat. Okay. And the third one is what we call the generated flavors. Okay, and this generation, right, is facilitated by the heat, which subsequently to chemical reactions. Like for example, dough, if you eat it, there's no taste, but during the baking, that's where the heat, facilitate the chemical reactions, and through the Maillard reaction for bread, right, it's Maillard reactions, they actually generate the flavors. Okay, as you start baking, and then at the end, they will generate a lot of molecules that can impart very important flavors. Another type is what we call the it can be generated by intrinsic and extrinsic enzymes. Like for example, meat. Okay, inside the meat, you got a lot of different type of the enzymes. So during aging, these enzymes start to produce different type. They break down the molecule and create a lot of flavor molecules. Okay, and extrinsic is basically like, for example, from outside. For example, it can be added like some bacteria, okay, or any type of like microorganisms that you added into the meat during the aging. So the enzyme from all these microorganisms, they will facilitate the generation of the flavors. So you can see there are different origins. It can be coming from plants, it can be synthesized, or it can be generated, okay, not from anything. It can be generated during like heating, it can be generated during the intrinsic or extrinsic enzyme during aging, or any other type of production. Okay, so all this will be discussed further through the following lectures. Okay, so now look at the very important area, which is definition of flavors. Flavors is the particular way a substance, like for example food or drink, is being recognized, okay, by the individual. And this recognition is basically a combination of these three areas. Okay, so for any flavors, like for example you eat certain food, okay, so it comes from what? From your tongue, okay, from the smell, combined with what we call the trigeminal perceptions. Is basically when they touch the nerve inside, it gives you sensation. This sensation, like for example the warmness, if there is any like pain, like for example like chili, okay, give you some certain type of pain, and etc. Okay, so these three things combine to give you the flavor of the food or drink. All right. So if you want to know more about the flavors, I have included in the chapter 1 handout. You can read more of that. Okay. So this over here is to illustrate the trigeminal nerves. Okay, from here the blue color one. Okay, you can see trigeminal nerves. Okay, that is the trigeminal perception from the food. You can receive from the food. Then you got taste, which is basically the tongue. And over here the yellow one, the hairy part on top here, is basically what we call the olfactory bulb or the nerve endings. Okay, where the smell, okay, go through the nostril, it will go through these olfactory bulbs, and this will send a signal to your brain, okay, to tell you to impart the flavors. Okay, let's look at the taste. Okay, taste is sensation produced or stimulated when the substance in the mouth reacted chemically with the taste receptor. So when you put a food into the mouth, when the molecule from the food reacted, okay, or bind to the what we call the taste bud. Okay, over here you can see this is the structure of the taste bud. So here this taste bud is all lined up in the tongue. Okay, so it's all around the tongue here. Yeah, so this taste bud got different concentrated at the different region. All right. So for the taste bud at this region of the tongue is give you the bitter sensation. This part of the tongue, the taste bud, this part of the tongue give you the sourness. This part of the tongue, the taste bud give you the salty, and here give you the sweet. Okay. All right. So these are basically the taste that you can get from the food. Okay, the taste. So first is taste, secondly is aroma. Aroma is kind of smell. Basically the food, okay, they have what we call the volatile molecule. All these volatile molecules all these volatile molecules are more come to your nose, is more actively come to your nose when it's warm. Alright, because of the kinetic energy. So when the smell molecule goes into your nose, alright, you interact with the receptor over here. Right? So when you react with the receptor, it will send the signal into your brain and tell you what kind of smell is that. So okay, so another thing is that one is come directly from the nose, okay, to the nerve over here. Okay, another one that is very important is when the food, okay, has been ingested inside your mouth. This is different from outside. When it's inside, okay, the food, okay, the volatile components will also go through to your nose. Okay, this pathway is what we call retronasal olfaction. Alright, and this will combine with the smell of the food and will send signal to your brain. Okay, the last one is basically what we call the trigeminal perceptions. Okay, so this trigeminal system is by these nerves. Okay, one of the largest nerve that you connect through your whole facial the nerves. Okay, the nerves here. And it's a chemical sense allowing for the perception of chemosensory information in our environment. The 4 dimensions that it can give you For example, the sensations of intensity. Whether is it very strong, is it weak, or is it strong? Okay, can give you the warmness. Okay, like from the capsaicin. The cold, like from the mint, and pain, it can from the capsaicin as well. Capsaicin is the chili. Okay, molecule from the chili. It gives you the heat and the pain sometimes. Alright. So, for example, the trigeminal receptor TRPA1 is highly activated by the cinnamon aldehyde, which is one of the compound from cinnamon. So, what happens is that when this compound you eat into the mouth, it will interact with the receptor. Once interacted with the receptor, it will produce a warm sensation. Okay, so you can try that. That's a sensation. So these three things come hand in hand. Alright, from the taste, from the smell, and from the trigeminal nerve perception, which is basically inside the mouth there, the nerves. So the just to distinguish further, all these molecules that can give you the taste as well as this sensation is what we call the functional molecules. So they will react with this region, the trigeminal nerves, okay, which is at this region what we call the autophagus, autogenous cavity, okay. So when it reacted with this area, it will give you the sensation. Okay, like for example, the capsaicin. Okay, this molecule will react. It will give you the heat, give you the pain. The cinnamon aldehyde give you the heat, and the menthol will give you the cooling. Okay, cooling sensation. Okay. Let's watch a video. This is basically the flavors perception from these three areas.
It's instinctual to give a beautiful plate a hearty sniff when it arrives on your table and soak in the aromas that contribute to flavor. But your nose doesn't stop working when food enters the mouth. Much like our tongue has receptors for the 5 tastes, our nose has receptors for the molecules that make up aromas. The receptors in a normally functioning nose send signals to our brain that are so accurate, we can easily distinguish between aroma molecules that differ by only 1 carbon atom. It's this specificity that allows us to differentiate variations on an aromatic theme, like the difference between fresh and spoiled milk. But despite what your brain might lead you to believe, smell doesn't stop when something enters your mouth. You can also smell food while it's inside your mouth. This is called retronasal olfaction, and it's a key player in the orchestra that is our flavor experience. Basically, once food is in your mouth, aroma molecules drift up the retronasal passage near the back of your throat, where they are treated the same as smells that came through the nostrils. The act of moving food around inside the mouth is what unlocks even more of these compounds and sends them up the retronasal passage. So many gears are turning in the mouth when we eat: salivating, chewing, and swallowing, plus the 5 tastes on the tongue. Our brain tricks us into thinking food aromas captured through retronasal olfaction come from the mouth too. But it's the combination of all those separate signals, from the mouth and nose, in the brain, that creates a fully unified flavor experience.
Alright, so there's talking about different areas. So you can see now, okay, that the taste, aroma, trigeminal perception give you the overall flavors. One more thing that I need to highlight is basically what we call the color. Alright, the color actually and the sound. The color and the sound can actually change the taste of food. Okay, how you perceive a type of food. Okay, let's watch this video.
How food tastes is not just determined by the ingredients used to make it. At a research kitchen in London, a psychology professor and a top chef are trying to see how big of a role perception plays. Mark Phillips did some taste testing to see how sound and smell can change the flavor.
The promotional video for this combined London restaurant and food lab sounds like a game show. And it is. Call it the spoon game.
Try to get into the chef's mind and arrange the spoons in the way that you imagine he might have thought.
4 spoons, 4 colored flavor balls, and Oxford University psychology professor Charles Spence makes you pick which color you think will provide which taste.
There's no right answers.
I hate when there's no right answer.
No right answers, but you'd be surprised at the number of people who give the same answer.
That's what I'm saying. I'm saying salty, bitter, sweet, no, sour and
then
sweet.
Okay.
Okay? You're doubting me already.
The proof is in the tasting.
It is sour. It tastes like what you'd expect green, tangy things to taste like. And this should be the sweet one, right?
It went on a sweet note.
Right. It turns out 3/4 of people associate the same colors with the same tastes and line the spoons up in the same way. So why is that useful? It is if you're trying to get people to eat less sugar.
If you're thinking about food and beverage companies who may be wanting to reduce the sugar in some of their drinks,
Just
say...
Make it red.
Yeah. And the third test...
And if you've passed the spoon test with, yes, flying colors, try the jelly bean test with a nose clamp.
This is not a piece about Oriental swimming, but let's go ahead.
What I'm going to do now is give you a jelly bean and taste it and think about what do you get.
On the Swedish side.
The game here is to taste the bean with the nose clamp on.
And suddenly you get the...
And then off.
Lemony.
This retronasal smell, whenever you swallow, a little pulse of volatile rich air comes out. That's where most of the taste really resides.
Right. What the taste buds on my tongue were telling me was what you called taste. When I took the clip off and got the whole hoo-ha of the thing, that's flavor. Okay.
And what people colloquially call taste.
Ladies and gentlemen, this is your captain speaking.
And that matters, for example, with airplane food. The dry cabin air and low pressure means, surprise, surprise, that you don't get the full flavor, which is why 20 to 30% more salt and sugar can be added to produce the same taste as on the ground. Appreciating the effect environment can have on taste, and even experimenting with bringing that environment to the table, is why airlines and food producers pay for the kind of research done here.
This is the vinegar, right? Yeah.
What if, for example, you're trying to get people to eat more sustainable food? In this case, something which has been swarming our coastlines, but which you probably would never have thought of putting on your plate.
So what you have here is a plate with jellyfish.
A dish enhanced by adding a seaside soundtrack.
So, headphones, jellyfish and gazpacho.
Chef Joseph Yusuf does a mean marinated jellyfish. Cue the music. It may not be at the top of everyone's list, but dress it up with a tabletop projection of ocean waves and add ocean sounds through the headphones and...
All this helps with kind of getting them into that place where they're excited about trying something new, excited about trying something different.
I'll tell you, this would be good enough without the music, but it's, I see your point.
The point is that as we move forward in what we eat, presentation counts, perhaps like never before. For CBS This Morning, I'm Mark Phillips in London.
Kind of want to eat every meal now with headphones on and waves crashing.
Sorry, no ocean music in the world could make it worth eating jellyfish, in my opinion.
Oh, it's good.
You tried it?
Yeah.
Oh, well.
I get it. I get it, how it's all connected.
Well, but it makes sense, though. When you have a cold, you can't really taste food as much.
It's all...
Alright, so the last part is... okay, this is second last slide. Okay. Alright. So this one is what I need you to do an activity after this. Alright, so please pay attention. So for example, I got this product over here is what we call the apple. The intended flavor for this product is a refreshing apple and melon flavored drink. Okay, you can see from this poster, got apple lemons. Okay, very appetizing, and there's like fizziness to give you that kind of refreshing of the perception. So what they need to do, okay, when during the production of this product is where they need to complement with the intended flavor. So what they do is they added the green colors to the drink. So the drink is green in color, okay, which makes it looks like the green apple and melons. Alright, and then they will need to put in the apple and melon flavor flavoring. Can be synthetic, okay, to give you the smell and the taste like apple and melons. Alright, and the last one is basically they need to carbonate it to give the fizziness. Okay, carbonated with carbon dioxide to give the fizziness or the refreshing sensation when drinking or during the opening of the can. Okay, so all these come together, okay, with this. And when the person consumes this product, they will have the signal that coming from this component into your brain and give you the flavors, the flavor perceived, which is basically the refreshing apple melon flavored drink. Alright, so this is a breakdown of what should be in the product to give you that kind of the perceived flavor. So what I need to do now is think about it. Alright, so every one of you, I want you to come just to search for a product, okay, online. It can be a drink, it can be a beverage, it can be a type of food. Just make it simple, because just want you to understand the different component that contribute to a perceived flavor. Alright, so what you need, you come up with a product. Okay, the intended flavor is this and this. Okay, what are the components inside that give you the sound, the sight, the smell, the taste, or the trigeminal, the perceptions, and to give you the flavor. So it's a very simple type of activity, just to give me an idea whether you understand the theory or not. Okay, and also give you a chance for you to practice what you have learned from this lecture. So what I need to do is that once you created this already, alright, then I want you to actually post your answer in Padlet. Each and every one of you post your answer in the image file into the Padlet. Okay, this is the link, and this I have give example over there in the Padlet as well. But if you want to access to the Padlet, you need to key in the password, which is COL63304. Alright, so I look forward. If you have any the question as well, you can post in the Padlet as well. Then I will answer from there. Okay, alright, thank you very much.